So we'll get underway. So just really like to acknowledge the contribution over the last 20 years, and the people listed here have made a huge contribution in terms of where we've got to in terms of New Zealand. So obviously Waka Kotahi, that's the Maori name for the agency I work for, the New Zealand Transport Agency, government agency, receives tax funding to manage the transport system in New Zealand. And three key contributors, so Dr. John Donovan, who some of you may know, he's now just retired from the New Zealand Transport Agency, but he has been pivotal in where we've got to with our policies. He led the charge very early in the early 1990s and been inspirational. He's also worked with WDM, so he's seen what it's like to be on the survey side, but also led the charge in terms of our policy development. Peter Sennett, very key in terms of the technical support, so he does a lot of the research for us, and I'll just acknowledge the input. A lot of the slides have been from the work that Peter's been doing as part of WSP research. And very sadly, the late Dr. Krista Kennedy, who was absolutely a leader in surface friction internationally, inspirational in terms of the Safer Roads Conference series that we've been having every 3 years. And I saw Dr. Chris as a world leader over the last 30 plus years in terms of the development of surface friction measurement and also collaborating and helping to share all the good information, all the learnings about the measurement of surface friction. So just wanted to make those acknowledgements for the people who've been instrumental in terms of our development in New Zealand. So just wanted to sort of set the scene, give you an overview of the New Zealand environment, just a bit of context, a little bit of history, and then really what the catalyst for change and why we've gone down this path and how we've embarked upon the journey. So for those of you that may not know, New Zealand, the Maori name is Aotearoa, and that translates to the land of the long white cloud. And you'll probably find the theme going through this presentation of weather has a big part to play in our environment. And so land of the long white cloud refers to the fact that we have some high mountains, that we have a lot of cloud and a lot of rain. And so it's sort of a little bit mystique, but that's the translation. In terms of New Zealand itself, we've got a population of just over 5 million people. And from a land area perspective, apologies, we're metric, so I've had to convert a lot of these to imperial, but it equates to about 103,000 square miles, which would be similar to the state of Colorado when you look at the land area. Our highest mountain is Mount Cook, 12,316 feet. That just gives you an idea of the elevation. And our country is obviously dominated by things like earthquakes, very vulnerable seismically, and you would have no doubt seen that in the news over the last 5 or 10 years. Volcanoes, but we are renowned for our scenery and our road environment, which is what we're going to sort of give a bit of context to now. So from a transport network perspective, we've got about 62,000 miles of road network in New Zealand. 55,000 of those is what we call local roads. So this is your small feeder roads onto your main arterials. And then the arterial network, which is we look after predominantly, is the 6,800 miles of the key highway network. So that's funded 100% by government, whereas the local roads is a split between national and local funding. Climate has a big part to play. We have a lot of variable weather located down in the South Pacific, very high rainfall to the west and dry to the east. And just as a bit of an indication, our driest area, Alexandra, down in the middle of the South Island, on average has 15 inches of rain per year. And then one of our mountains in the North Island got 13 inches in one day. So you can sort of see that there's a fair bit of variability in terms of the rainfall that we get. That does tend to dominate, and weather probably dominates almost more than sport in terms of the New Zealand lifestyle and the conversation that goes on, because it's always changing. Topography is with a large mountain range running sort of basically north to south up through the islands, and our road network is a tortuous typically two-lane road, and about 38% of it is actually unsealed. So a lot of those local roads are just gravel roads. So hopefully that just sort of sets a bit of context for you in terms of what we like in terms of the country. And then the topic of today's conversation is really the crux of all of this is about saving lives, and I'm passionate about road safety and about saving lives, and through through the work that we've done, we've taken a proactive approach to the transport system management. We defined that we obviously had a problem with our surface friction. So it was really a challenge then to say, what is this problem? And it was really a high percentage of wet road run off the road crashes. So typically single vehicles, wet road, slippery, braking, and the crash develops. So we then had to find a fit for purpose solution. And this is when we embarked upon the journey before I started with what was then Transit New Zealand, looking at road surface friction, which captures a whole range of disciplines. And as we go through today's presentation, you'll see the complexity. And I'm sure most of you are aware about the measurement and what you do with the information. It covers a wide range. And obviously there's a lot of variables as well in terms of the way in which you measure the information you get, basically the number you get, and then how you act upon it. So we've combined all those and developed what we call a realistic action plan, and this is really sort of taking an affirmative step towards making a significant improvement. And so the story today is basically this 20 years of that progress towards making our roads safer. So just to set a bit of context, I just wanted to give you a snapshot slide of our statistics in New Zealand. So unfortunately last year 353 people died on our road network. And we collect a lot of information in terms of the crashes, and we can use this to highlight the causal factors, the type of people involved, the circumstances in which they died or were seriously injured, and use this information to help then target our improvement program. So I thought I'd just give you that snapshot, and you can sort of see what some of the key things were. So of those 353, 177 died on our highway network. So high percentage died on our main arterial network. 182 deaths involved the vehicle hitting a roadside object. So this is where we're really targeting how we can make our road environments a lot safer by not only putting up safety barriers, but also trying to prevent people running off the road by improving our road surface friction. So in doing so, a few years ago, we embarked upon realizing that the road network requires a holistic approach. So we've developed what we call the safe system approach, and this is looking at the contribution we can make. And the key vision here is that making a safe road system increasingly free of death and serious injury. And at the end of this presentation, I'll say how we've taken that even one step further. But that was our focus, was how can we make the total system, which is made up of safer roads and roadsides, which is the focus of today, but also safer speeds for people that travel, having safer vehicles, and then obviously safe road use, which is the sort of the driver perspective. So in New Zealand, we do have a lot of older vehicles, so we're finding that a large number of people are dying in what we call 1- and 2-star rated cars. So we aim for 5-star rated cars, new vehicles, but some of the older vehicles, 20 years plus in age, a lot of people dying in those vehicles that are not fit for today's road environment. So that just gives you an idea of the sort of focus we have in terms of those 4 themes coming together. So just a little bit of background. I just want to acknowledge that there was a paper given back in 2005 at the first conference around there's a fraction, too little friction. And this really is a paper that sort of encapsulates what we did through the 90s. So back in the 70s and 80s, we had some very early guidelines for providing skid resistance. It was very, what you might call reactive. And then through into the early 90s, we started to look at doing network surveys to look at the condition of our road environment. And we were doing these every 3 years. And we obviously focused on the ones that are easy to measure. For example, roughness, that's a really good, easy to describe and measure the roughness of a road network. And we were using these for our condition indicators. And then when we started to get into measuring skid resistance in the late 1990s, we initially had 2 network surveys. So we had 2 vehicles traveling the network, picking up condition. But working with WDM, we managed to get these combined into 1 vehicle. And that's the scrim machine that we'll be talking about later on in this presentation. So quite a bit of development and efficiency gained by pulling those 2 pieces of kit together. And then we also very early targeted polished stone value. So this is the measure of the aggregate's polishing performance, and we had some requirements for the PSV of the aggregate that was used in our resurfacing program. And in the mid-90s, the survey that we did highlighted that about 25% of our highway network was at or below what we would class as sort of our investigatory levels. So that was really a trigger to say, we can make significant gains by targeting that 25%. So we did some quite significant research, and that out of that came our investigatory skid resistance levels, and we'll show a table later on to show what they are. But this was looking at the whole network, dividing it up by risk, and identifying what the trigger levels were for us to start investigating. And so that's now evolved into doing regular full network surveys in both directions. So we measure about 13,670 miles per year across our highway network, along with some of the local councils do periodic surveys of the road network as well. So in terms of the research that helped to develop our policy, so we WDM conducted this research using both the network conditions survey data and also the crash data. And from that, they developed the investigatory wet road skid resistance levels for New Zealand State Highway Road Network. So it was really using that information measured off our network compared to our crash data to develop a policy for us. Now, we did base this on the UK standard, but we had to adapt it for the New Zealand crash risk and the type of network and our network segmentation. And this was really a key factor in terms of us targeting to risk. And when they did this analysis, it showed there was a statistically significant relationship between wet road crashes and skid resistance. This was second order rather than direct, but it certainly was gave us the information to then decide that we needed to do something about it. And when we're looking at investing new money into doing activities, we back in the day had what we called a benefit cost ratio. So we look at the benefits of doing something versus the cost of doing that. And typically back in the day, we were funding projects around the benefits of 4 to 1. So if the benefits outweigh the cost by 4 to 1, we would invest. When we did this first investigation, we found we had a 40 to 1 opportunity to improve the network. So this was actually just absolutely amazing in terms of the benefits that we could achieve by doing a modest investment in terms of improving our surface friction. This was later refined as we went and looked at the crash data, because you do have to make some assumptions about what crashes you can save by improving the road surface friction. And obviously crashes can be a number of factors and may not all be involving loss of grip. So we did refine that down, but it certainly was the launch pad for us to decide that there was huge value in investing in this area. It was peer reviewed, and then obviously our landmark policy decision was made. Now, in doing this, the important thing was the data. It's really important if you're doing an analysis like this that you've got to have good data. So we have a national crash analysis system, a CAS database, and this is where all our crash data is captured. And from there, as the earlier slide showed, we can interrogate that data and do some real investigation in terms of the type of vehicles, the age of the drivers, the driving conditions, and what could be seen as the causal factors. So that allowed us to go in and identify the wet road loss of control crashes. And then we compared this to the network asset condition data. So again, we're collecting masses of data annually on the condition of the road network, skid resistance being one of those, and that's why we could use those to do that research. And at the same time, location referencing, there was a really big issue in terms of when you're doing surveys year on year, you do need to be able to compare the same spot year after year. So location referencing was really important, and we put all those factors together. So the findings really sort of launched a new era for us, and I think the key thing I want to reinforce today is the fact that it allowed a proactive approach to road surface treatment to prevent these crashes. Often we'd been reacting to what we call black spots where we had known crashes, but through this policy, it allowed us to do an analysis of our whole network and then look at a proactive approach as to where we could invest. And these levels of service determined what the level should be, and that then helped us prioritise where we needed to invest our money. And through the policy that was put up, that managed to extract extra funding. So funding was improved for us to do an initial intervention and go and target the higher risk areas, but also to continue an ongoing program of skid resistance investment. And that's why using that benefit cost ratio really helped us to justify this increased investment. Along with that, we developed a task force. So, you know, it's all very well to develop a policy, but you've got to have people who understand it and can help implement it across the country. So we set up what we call a skid technical advisory group, a range of people across the country who had a passion for this, and could help with some of the complexities of how we rolled out this policy. So the policies here are what we call our T10 skid resistance, and it's a technical specification developed, and we'll go through in the second session a bit more detail about what that involves. But the crux of it was these investigatory or risk levels established for the New Zealand road environment. Thanks, Roland. That's the end of session 1.
Thanks, Mark. So when I kind of think about the past 20 years, obviously programs change with new technologies. There are new priorities, there are new learnings, and a lot of research has gone into this, and so you've kind of set us up now to watch a couple of decades of that learning on fast forward. But before we do, I will stop for a second and ask our audience again to add their thoughts. So coming up is another poll. The poll question is, should friction treatments be managed on a systemic or a spot basis? So systemic, spot, it depends, or unsure, I don't know. And this will become apparent in the next section on how policy analysis and treatment dovetail within the New Zealand context. So I think once we get an answer back from everyone, I'll give them a couple more seconds. It looks like about 50% are saying it depends, and so maybe that's where we can focus some guidance, but about 40% are looking at friction and friction treatments as a systemic question. So a question then for you, Mark. How does the way that NZTA's program is structured influence a question like when are high friction surface treatments deployed, or when systemic versus spot treatments are called for? So how does this program structure influence that?
And I think both answers are right. So you can look at sampling, which is where you take sort of spot treatments, or you can do a full network assessment. And my view is we really encourage road owners to cut the cloth to suit. So not everybody can afford to do annual surveys on their whole network. So my advice is take small steps. If sampling is the first foray into this, that's great. You can just really want to start to make a difference in your high risk areas, and then you might work your way towards doing full network assessment. But we'll talk about that as we go through session 2, and hopefully give a few insights in terms of the difference between the sampling and full network survey.